Morning, all of you. So, let me introduce myself first. Myself, Professor Amrish Bhavsar, and I am head of the department in civil engineering branch. Your one of the new subject, that is mechanics of solid, is now start. So, first of all, from this subject, what we can understand? Mechanics of solids. So, we all know about the solids, what is solids, and that you have studied in 11th 12th. But before that, we have to understand mechanics. So, what is mechanics? Many of you have number of time heard the word, that is science. So, what is science? Let me clear. Science is the huge branch. In that, there is chemical composition of all the activities done surrounding us, that is chemistry, and that you have studied. Then physics, that also you have studied. So, what is physics? It is also a huge branch. Now, from that science, we are going to take some of the small part in which we are going to understand about the motion of the body, motion of the particle. That is called mechanics. So, let's understand engineering mechanics. Mechanics is the branch of science which deals with the state of rest or motion of the particle and body under the action of force. That is called mechanics. Means, whenever we are going to apply a force on any body, after that we are going to study the position, whether it is move or not move. If it is move, then why that element or else that body move, and if it is still remaining in position of rest, then why it is not moved. This kind of study from the whole science we are going to understand. That is called mechanics. So, this engineering mechanics is totally depending on the our previous subject that you have studied in previous 11th 12th, that is physics. In physics, you have studied lots of things, but the major thing that is in that subject, you have understand only the things that is principle of the physics. But now, from that principles, we are going to apply that principle on particular subject, and we are carried out some solution regarding to engineering problem, that is called mechanics of solids. So, basically Mechanics of solid is the combination of mathematical steps that we are using for the solution of anything, and the concept, principles of that physics, that combination is create the whole subject. So in applied mechanics, the approach is to study systematically the law of mechanics and their application to the engineering problem. In this, we are using law of mechanics and principles of physics, and that used in solution of engineering problem, that is called applied mechanics. Means we are applying the laws of physics and mathematics, that's why it is called applied mechanics. So this mechanics is the branch of science, and the applied mechanics is the application of mechanics to engineering problem. Now this mechanics is divided in three parts. First one is mechanics of rigid bodies. What is the rigid body? You know, whenever we are going to apply a force on any body, and that body cannot change its shape and size, that is called rigid body. But whenever we are going to apply force on any body, before moving it is compressed or it is tense, whatever, means the deformation of that particular body, that is called mechanics of deformable bodies. And third one is mechanics of fluids. This fluid, mechanics of this fluid will be studied by you in further semesters in detail. But in this applied mechanics, we are going to study only the two things, that is mechanics of rigid bodies as well as mechanics of deformable bodies. This rigid body is a part of engineering mechanics, and the deformable body is a part of strength of material. In that, we are going to understand the strength of all the material that we are used in engineering. So in engineering mechanics, means in rigid body, there are two types. First one is static and second one is dynamic. Means when we are going to apply force on a rigid body, then it is moved or it can't be moved. So whenever it can't be moved, it is the position in rest. But if the body can move, then it is the position in dynamic. So that dynamic position, means motion of that body, is divided in two parts. First one is kinetic and second one is kinematic. What is the meaning of kinematic? The study of motion of body, and force is responsible for the motion, that is called kinematic. But if the body will move without force, that is called kinematics. So this is the fundamental things of applied mechanics that we are going to study in this whole subject. Now, what is the fundamental concept? In this, we are going to study about the space. So you know what is space. Space is the region in all the direction and contain everything within its. As for example, sun, star, planets, etc. We know about the space. Time, we know what is the time. It is the duration between two successive events. matter that also we studied in physics. The substances that processes weight occupies the space and that can be approached by the sense in called matter. What is body? That we know, any rigid body. Inertia, that also you can know in detail. What is mass? That you have studied in physics. Rest means its position, standing position, that is called rest. And motion, whenever the body is in moving, that is called motion. So this is the fundamental concept that we are going to use in engineering mechanics. Now, idealization of mechanics. Again, the things that used in this mechanics that we have studied previously in physics, as we discussed, the engineering mechanics means mechanics of solid. The whole subject is totally depending on the physics. So, the idealization of this physics means mechanics that understand by you in physics what is particle, what is rigid body, what is deformable body, what is continuum, the whole things that you know. As I said, the rigid body means a body is said to be rigid if the relative distance between two particles of the body remains same before and after the application of force. Means it can't be moved. But what is deformable body? A body is said to be deformable if its size and shape changed under the application of external force. That is called deformable body. So, these the common things that we are used. Now, the most important thing, that is fundamental principles of mechanics. You know who is the founder of this motion? That one of the men, and we know his name, that is Newton. Whenever you had studied that physics and you have heard one story of that apple, that guy Newton, founder of the engineering. Why? Because without motion, engineering is zero. Whether it is mechanical branch, whether it is in civil branch, electrical, whatever, which kind of branch, the things that is whole these branches are related to motion, and the founder of that motion is Newton. He had given us the basic fundamentals of mechanics. That fundamental is known as principles of mechanics. So, which are the that principles? The elementary mechanics rest on a few fundamental principles based on experimental observation. न्यूटन ने हमको 4 रूल दिए थे, एंड वी नो दैट रूल. Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, and Newton's law of gravitation. that we know very well. But again, the three new fundamentals, that is important now for this subject, and that is parallelogram law of forces, principles of transmissibility, and principles of superposition of forces. So these 7 principles are used for the solution of engineering problems. So the again most important thing, that is fundamental units. You know, and you have studied in physics, they measure units, that is made from the 3 fundamental units, that is length, mass and time, regarding to engineering. There are some other units are there, but whenever we are going to use this unit in engineering, that is totally depending on these 3 units, that is length, mass and time. From this we can make the equation, and the unit of these fundamental quantities are called the fundamental units or base units. Derived unit, the unit of some physical quantities, are derived from the fundamental units. Such units are called as derived unit, like area, velocity, acceleration. Let's try to understand this. The unit of this area, that is meter square. So it is regarding to length. Velocity, unit of this velocity is meter per second. You know, this unit, meter per second, means it is depending on length and time. Again, the acceleration, that is meter per second square, it is also depending on length and time. Weight of any element, force, this all totally depending on that mass. So these 3 unit, length, mass and time, is very much important for us. From that unit we have some system of unit, and this system of units is adopted by different countries. Like in India, all the units are in MKS system, means meter kilogram second. Let's try to understand. Here in India, all the distances are used, that is measured in meter. All the weights that we are used in kilogram, and the time is always remain same for all the countries, that is second. But the FPS system, foot pound second, this system is adopted by European countries. Again, centimeter gram second, it is adopted by some another countries. So the different country are used this system. So in India we are using MKS system, and this is called SI system. From this, suppose we are going to refer any drawing, all the dimensions are in meter. Suppose we are purchase anything, that is, the weight is measured in kilogram. This is our Indian system. So, foot pound second, basically it is the system of European. But till we are using that system in India, we are using the dimension in feet till today. But how it is possible? You know, the thing that is, before number of years ago, the Europeans were in India and they have teach us the dimension how to measure, but their European system is foot pound second. So we are using that system and familiar with that system. Till today we are using, but whenever we are going to submit our drawings and with government we are dealing anything, in that case we must have to use this MKS system for that. Now, from this system we have to convert our units from kg to kilonewton, meter to foot, foot to meter, because we are dealing with all kind of units. So, the most important thing, that is, we have the knowledge of conversions. Without conversion we can't do anything, because if I am going to take force and unit of that force, that is kilonewton, because the force is find out by the Newton and unit is fixed for the force, that is Newton. But we have the things that is measured in kilogram. So, if we are going to do some calculation, that we have to convert kg to kilonewton, because our all the equations are made up from the kilonewton unit. So, these are the conversion, these are the basic science that you studied in physics. Now, the conversions is most important. So, these are the basic conversions for the distance, weight and other units. So, this is the basic thing that you must have to know how to convert it. And what is scalar quantity and what is vector quantity, from that we have studied in physics also. Sadish Rashi and Adish Rashi. The scalar quantity is one of which can be completed specified by the magnitude only. For example, length, distance, area, volume, time, work, mass, density, temperature, speed, energy, mass, moment of inertia. These are the scalar quantity in which only magnitude is there. But in vector quantity, the direction and magnitude both are there. The vector quantity is one of the required magnitude and direction both to complete and specify it. For example, displacement, velocity, acceleration, momentum, moment, force, weight, angular displacement, all the things that is vector quantity. So, these are the basic things that we are going to use in this subject, and this is the introduction of our subject. Clear? So, thank you very much.